Picture this, you land on a website and bam! The web hero is the first thing you see, front and center. It's that eye-catching banner or section at the top of the page that immediately grabs your attention. Like a YouTuber's catchy intro, it sets the tone and makes you want to stick around for more. Or sends you away if it's super dull or non-inspiring like my hero. Anyway, I really like how Linktree has taken up the hero challenge. The left section is as simple as hero sections get, just a title, a description, and an action button. But the right, it shows you the product in all of its glory. In fact, it shows you 10 variations of it, all of them in 3D space, and rotating all of the time, grabbing your attention as soon as you hold the site, and overheating your CPU at the same time. But are those animations really 3D? Or are they just some cleverly placed and animated diffs? I say we recreate this bad boy from scratch and find out ourselves. Let's start simple, by just creating a box. Nothing else, just a box. Or we can, start with the default box, delete it and create a new one. Okay, we have a square. Now what? We see that Linktree's cards are affected by the mouse movement. Yes, they spin around and stuff, but the rotation of all of them and their 3Dness relies on the mouse. You can see that they follow my cursor as I move around. But are they actually? If we observe carefully, we can see that the cards are facing us directly when the mouse is at the exact middle of the screen. That means that the cards actually think they are in the middle and not off to the side. With that knowledge on the table, we can infer that all calculations are done to the screen and don't have anything to do with the card's position, which actually simplifies the process a lot and spares some CPU resource. Clever. We just have to know the coordinates of the screen's origin, which is basically halving both the sides. And after loading, they don't change like ever. Well, of course, only if you don't have some fancy expandable, foldable, transformable screen, but the chances are you don't. Moving on! To get the mouse cursor position on the screen and keep getting it as it moves around, we have to use an event listener. So let's create one. And to get the X and Y of the cursor at any given time, we just have to extract them from the event object. Perfect. And if we add them to a console log, or better, to the DOM, we can clearly see the coordinates of the mouse. Sweet. But how do we get them relative to the center of the screen? Well, that is easy too. We just have to subtract our coordinates with the nuance from middle screen length and bam, we have a coordinate system, the one with quadrants and stuff. And to ease you into the next part, I'm going to grab the offset percentages of the cursor by dividing the current coordinate by the whole width or height and then multiplying by 100. That way, when our mouse is at the top right corner, it will read 50% and 50%. And when it is in the bottom left, it will read -50, -50. You get that? Cool. Now we have the chords of the mouse and the offset percentages too. So, how do we make the box look at the cursor? Well, that is quite easy too, my friend. We know all about that transform property, right? That uses this super easy formula to calculate the quaternion of that object with that rotate 3D function. Yeah, we ain't using that. Instead, we will use the rotate X and rotate Y functions from the transform property. See, when I pass just one function, let's say the rotate X1, and then pass the X percentage as a degree, the card starts following the mouse in the inline direction. And when I pass the Y percentage to rotate Y, it follows the mouse in the block direction. So, when I pass them both, I get, that's right, a card that follows my mouse. I can divide a percentage by some number to numb the effect so that it's not that extreme, and look at it, we have a rotating card, just like that. Okay, but Linktree has a bunch of them, and they're not just one card, there are many. Heck, they're not even on the same plane. How is that done? Well, let's add some elements to our component and then figure it out. I'm first going to create a plane that will house our global rotation, and then a card with some placeholder junk in it to show the effect. You see, if we want to have things look like they're in front of others, we have to move them on the z-axis. And I'm not talking about z-index here. We have to tell them that they are, in theory, closer to our eyes. But how do we do that? Well, transform, translate, right? And that there is a translate X that moves the element on the horizontal axis and a translate Y that moves it up and down. Well, there is actually a third function that moves it on the Z-axis, called, drum roll please, translate Z, and we can tell it how far or how close we want that element to be. Okay, let's give some of the boxes that. Nothing happens. Why is that? Well, by default, the HTML elements are at an infinite perspective. That means that no matter how close a thing is to us, it will appear at its absolute height. You have the same effect in real life if you look at things at a great distance. If we want that thing to appear closer, we have to give it a perspective. So let's do that. Before the translate Z, we can type in the perspective function and give it some value, the maximum depth we want. Or we can just put it as a property on the parent so that all elements inherit it. After we added the perspective, we can see that our boxes grew in size. Neat! But when I rotate the master box, they just appear bigger, but are actually still glued to it. That's because we have not told the box that we want it to be in 3D when it rotates. Now it just stacks things, it gives them some illusional depth, but when we rotate it, it just shows all that depth as a flat 2D projection. What we can do is set the first magical 3D property, Transform Style, Preserve 3D. This property actually tells our elements that they now exist in 3D space and do not need to flatten themselves. And our images and boxes actually hover over our cards as we move the mouse. Well, isn't that super cool? And pretty easy for the amazing effect it delivers. Okay, most of the work is done actually. Now we should only create some fancy cards. Let's create a project showcase card. It will have a phone-like card with some UI elements inside, a card to the left, a card to the right, some circles at the bottom, and a halo for effect. Yeah, that's enough. Now we should create a bunch of these cards and just put them on top of each other, so that they occupy the same space. Let's create a grid and use the grid overlap trick, where you can set all items to be in the same cell by setting the colon row start to be 1. Alright, now we have 4 elements that are stacked on top of each other. We can't actually see them because they are all flattened. To make them spin, we first have to do a change in the HTML file and one in the CSS file. The CSS change is simple. I'm going to add some local variables to the card, one for the local rotation and one for the scale. I'm going to set them to be 180 degrees and 0 respectively, the state of the hidden card. After that, we go to the HTML, where we add a data index attribute to the cards with their respective index. Remember, in programming, we count up from 0, not 1. That property is most easily added when using a framework and a map function. But since I'm a masochist, I will add it to each card separately. We will also add a data selected to the first one so that it's selected by default, and add all of the inline styles that make it visible. That is, the local rotation 0 degrees, the scale of 1, and the visibility of visible. And while we are here, I'm going to add a data animate attribute on all of the objects I want to fade in after the flip, and the actual animation class on the first component's children. Very simple, right? Cool. Back to the script. We start by grabbing all the cards with a query selector. That way we know how many cards we have in our spinning widget. After that, I'm going to create 2 functions. One called select and one called, you guessed it, unselect. They both will need a parameter called index, and they will do one simple thing. Move the selected property from one card to the other. Well, they actually set some style props too. Let me explain that. We first get our card with a query selector. No surprise there. Then we either add or remove the data selected attribute from it. After that, we have to set some styles. And I know I could just set them in the CSS based on the data selected attribute, but I did it this way and I'm too lazy to change it now, so don't judge, please. We'll first start the select function by setting the visibility to visible, so that our card is, well, visible. Then we set the local rotation variable to 0 degrees, the scale to 1, and the opacity to 1. Note that you have to set the transition on the card for this to work. After I've styled the card, I want to get all of its children with the data animation attribute on them and toggle it on. And that's it for the select function. Now for the unselect one, which does the same thing but backwards, with one little exception. We first set the rotation on the card to 180 degrees, so that it turns around. Then we set the scale and opacity to 0, so that it shrinks and disappears. After that, we add a timeout function of 300 milliseconds and set the visibility to hidden, so that the card actually vanishes. Then we add another timeout and set the rotation again, this time to negative 180 degrees. We do that because the cards have to flip around from different directions, and without this little change, when the next iteration comes, one card will rotate from 0 to 180 and the other from 180 to 0, which means they will crash into each other and the universe will explode! But when we set the rotation to negative 180, they will spin around each other. You spin me right round, baby, right round, like a record, baby, right round, round, round. Cool, we have 2 functions. Now we have to cycle them. Let's add an interval with a 3000 millisecond delay. Inside, we will get the selected card's index, then we will call unselect, after which we will do a check. If the current index is the last one, we will call select with 0. If it's not, we will add 1 to the current index and pass it to select. And that, ladies and gentlemen, is the magical super optimized function that tops off our animated hero. If you wish to add more animations like this to your website, make sure to check my last video on scroll animations. And if you like that video, consider hitting the thumbs up and checking the code pen. I was Fastlane Costa, and thanks for watching. Bye!